Children, as our part 2 video of electricity, now I have a paper bits over here. I am going to demonstrate the transfer of charges by friction. Okay, so I have small bits of paper here. On that I am going to show the scale, but in your book it is explained with the help of a comb. Okay, so I am replacing the comb and with the scale, and this scale I am going to rub on my dry air. Okay, you also try this at home. Okay, just I will form this, rub this scale on my dry air and bring it now. Just watch, children. See how the papers are attracted. See, one more time I will try. Just see, children, can you see the paper bits get attracted over the scale? For this, the reason I will explain in the video, children. Hello, children. You had seen that activity. So, explanation regarding that activity we are going to see in the content. Now, what we have learned in the previous lesson. So, previous video we have learned about the structure of atom, what are all the subatomic particles, what is present inside the nucleus, what is revolving around the nucleus, what is the total charge of the atom, what is the charge of the nucleus, all those we have seen. And outermost electrons are strongly attracted and it can be easily removed, and those which are inside closer to the nucleus are strongly attracted and cannot be easily removed. All those points we have seen, right? Do you remember that? Just if you have not remembered that, just pause the video and go to it, because without that idea this cannot be understood, right? Okay, now in this content we are going to see about transfer of charges, flow of charges and electric circuits, right? So in the previous video itself I had quoted these three methods. There are three methods for transfer of charges. They are transfer by friction, transfer of charges by conduction and transfer of charges by what? Induction. Okay, so three methods. What are they? Friction, conduction and induction. Right. Now first, friction, transfer of charges by friction. That is what I had explained now. What I had first, bits of paper. Right. So friction means what, children? Friction means what? Moving of bodies, moving on one another. We learned in the force, pressure and friction lesson. Right. So now here I had taken a scale here instead of form here. That scale plus air. Right. When I rub the scale on my air, what will happen? The scale will get electrons on rubbing. The electrons from the air will get transferred to the scale. Right. So, scale is gaining electron. Electrons will have what charge? Negative charge. So, as it is gaining electrons, what will happen? Comb will become negative charge. So, air becomes positive charge. So, clear? So, now what the paper will have? What charge? Positive charge. Because we are clearing the paper, it is bits and bits of paper. Now, at the edges, both positive and negative charges will be, spreaded. And so, now when we bring the negatively charged scale or comb near the paper bits, it is having negative charge, and the paper bits having positive charges will get attracted to the scale. That is what the explanation. Here we are rubbing the scale on our dry air. No. So moving. So that is called friction here. Right. So this charging the paper, charges are transferred from the air to what? Scale or the comb. And then from the comb to the paper. So that is all due to friction. Okay, children. Now, okay, here if an object is not charged, uncharged object, if an object is neutral, how it can be charged, right? So a neutral object can be charged, can be made to have, in particular, can be made to have negative charge by gaining electrons, right? So that is what the concept I had explained here as a name. A neutral object is there. If it is going to be negatively charged means it has to gain electrons. Okay. Similarly, you cannot think If a body is going to be positively charged, it should gain protons, not like that, children. An object can be positively charged if it loses negative charge, right? Like here, air is losing electrons, so it becomes positive. If combing is that comb or the scale gains electrons, so it becomes negative charge. Clear, children? So losing electrons means positive, gaining electrons means negative. So positive charge, there is no role of protons here, right, children? Next one. Now a similar example I can give you. If a glass rod, a rod made up of glass is rubbed with silk, right? Silk, ordinary silk cloth, sarees and all we have now. There, if it is glass rod is rubbed with silk, what will happen? Here glass rod will give some electrons to the silk cloth. So which is losing? Glass rod is giving electrons, losing electrons. So glass rod will become positive and silk rod as it is gaining electrons, it will become negative. So another example also is explained in your textbook. We have ebonite rod and fur. Fur means a woolen cloth, right? Like sweater, what is that one? Fluffy like sweater, right? So they are all fur cloth. Another variety of wool, right? Now in this, fur will give some electrons to the ebonite rod. So ebonite rod is gaining electrons, so it will become negative charge. Fur loses electrons, so it will become positive. So while learning, children, this will confuse you. So kindly have one short point and note as per your convenience to remember it. Glass rod will become positive, silk will become negative, ebonite rod will become negative, fur will become positive. Here, I have written one point here, attraction and repulsion. Now, when two objects are closer to each other, now in the paper bit experiment also you can see, when I bring the scale very near, very close to the paper only, it will get attracted, right? When the distance increases, that attraction or repulsion won't happen. Okay, so attraction or repulsion of charged objects depend upon how closer they are kept. Okay, children. So these are the points you have to learn under this heading. Now we are moving to transfer by conduction. This is the very common example what we see in our daily life. How many of you have the experience of getting shock? Right, when you touch a switch with your wet hands and all. What will happen? Current, when we touch the switch, current by leakage with the wet hand, what will happen? It will flow into our body. When we touch, no, the charges is conducted by us. Right? So transfer of charges when bodies are in contact, when they touch each other, and it is called transfer by conduction. Okay. Now here I had in your book it is explained with an example of paper cylinder and ebonite rod. Now with a paper, we will make a cylinder. Right? This is very simple experiment only. I can explain you, and real time examples will be more effective than this. Right? Right. Now when we have a paper, make a paper in the form of a cylinder. Right. Now near that cylinder, if you bring an ebonite rod, already the ebonite rod rubbed with fur will get what charge? Negative charge. Now what will happen? When the ebonite rod is brought near the paper cylinder, let this be ebonite rod and paper cylinder. Now when I brought near this, ebonite rod rubbed with fur will get what charge? Negative charge. Now what will happen? This negative charge will get attracted by the positive charge of the paper cylinder, right? So now here, now the paper cylinder will be also made to be negative. This is also negative. When it is brought near together, what will happen? Negative and negative will repel each other. So now one concept which you had already learned in your lower classes, now I am recalling it again. Like charges repel each other. Like means what? Positive, positive, negative, negative. Like charges will repel. Repel means moving apart. Unlike charges attract each other. Underline these lines in your book. Already I had explained this, right? Unlike means what? Positive with negative, negative with positive, right? Proton and electron. Proton, proton, electron, electron. Like this, right? Vapor cylinder is negative now after bringing the ebonite rod, and ebonite rod is also negative. So that will repel, right? You can see, you would have seen so many videos on YouTube and Google and all. When two balloons rub on your body, right? Rub on a cloth or a towel, right? When blow up two balloons, rub on a cloth, both the balloons, and bring both the balloons together, it will get repelled out. Right? So what is that meaning? Bodies having same charges will repel. Bodies having opposite charges will get attracted. Right? So that is the concept here. Now we have in the box, that do you know box or no more box, you have this content. This you would have learned. Right? So any body which will conduct the current easily when touching it. Right? For example, our wet hand we said no. So water with more salts in it. Right? And next, metals, copper, aluminium, steel, what is that? Bronze, our wires and all are made of metals only, because metals are good conductors. And materials which do not conduct current, they are called insulators. Plastic, rubber, wood, they are called insulators. Okay, children? So these are all the 2 mark questions will be asked. So mark everything, whatever there in your book, whatever we are discussing here. Right. Second method we are going is third method. Third method is transfer by induction. The word itself says induce. So induce means what? What is that? Provoking. Right. So creating. Right. Without any contact, if charges are transferred, that method is called as transfer by induction. Here, charging will be done by bringing a charged object nearer to an uncharged object, but they won't touch each other, right? So charging by bringing near but not in contact. But these 2 lines I'll explain you afterwards after explaining this, right? Now here an uncharged body is taken, a body with full of charges, right? Both positive and negative are there. Now when I bring one negatively charged rod, example here, ebonite rod rubbed with fur, right? So when I bring an ebonite rod here, ebonite rod after rubbing, what charge it will have? Negative, right? Here positive and negative charges are mixed with each other. Right? Now what will happen? This will have negative charge. Negative charge, what it will do? It will attract what charge? Unlike charge. What is unlike charge for negative charge? Positive. So what will happen? All the positive charges will be attracted to this end towards this negative charge. So the remaining negative charge will move to the far end. So nearer end to the negative ebonite rod will get positive, far end will get negative. Now I am coming to this point, right? Nearer end will have opposite charge. Now see what charge does it have? Negative charge. Nearer end, this will be the nearer end. On that nearer end, what charge it will have? Opposite charge. What is opposite charge means? Plus here. So plus will be, if this is minus, opposite charge plus will be there accumulated in the nearer end, and the similar charge, negative and negative, will be there at the far end. That is what I have written here. So note this point, very important. In neat question, this question will surely come with twisted choice, as usual, right? Now what will happen? Now this negative charges can be removed completely by earthing this plate. Earthing means in a house and all we would have done, right? Earthing means we will explain that later, right? So we can when we earth this material, all these charges will go down, right? Now what will happen? This positive charge will completely spread out, so the whole body will be charged with positive charges. Clear, children? So now, before it was neutral object, both plus and minus together. Now this is entirely charged with positive charges. Clear, children? Next one. Now how the charges will flow? How charges will flow? Now I have example 2 bodies, right? One had lower potential and one another had higher potential, right? So lower potential means deficiency of electrons here, and one have excess of electrons. The body having excess of electrons will be called as it is at higher potential, and a body having deficiency of electrons is called as at lower potential. This count of electrons, strength of electrons is called as potential of a body. Right? The strongness, strength of charges in a body is called as potential. So more electrons means high potential, less electrons means low potential. Right? Now usually what will happen children? This lower potential body, from that electrons will get transferred to the body at higher potential. Now these electrons are transferred here. Right? When they will get transferred? When there is some difference in the potentials. One should be at lower potential and one should be at higher potential. Only then electrons can move. This difference in the potential, no children, from one body to another body, that is called potential difference. It is otherwise called as voltage. Voltage, we say at our home, low voltage, high voltage, like that. No, that is called potential difference. Right? What is potential difference? For example, when we are switching on the fan, right? Now our switch circuit will be at one potential and fan will be at another potential, and there should be some difference of potentials. Then only charging will be flow of charges will happen from one area to another. So for the electrons to flow, there should be some potential difference, which is otherwise called as voltage. Its symbol is capital V. Okay. Now this flow of electrons, when there is a potential difference, potential means for individual object. When there is a difference, it is potential difference. When it flows from one body to another body, then it is called as electric current. Its symbol is capital I. Okay, remember, current symbol is I, voltage symbol is V. Right? Now, we are moving to one another concept called conventional current. So, these topics are the development which happened in the 20th century, which is still proceeding even in 21st century. Before this discovery of electrons and all, scientists were believing, they were working on the experiments, believing that current is the flow of positive charges. Right? So now after that discovery is made that electrons are due to flow of electrons. Right? So now that current which was assumed by the scientists to be flowing from positive to negative, they called it with one name called as conventional current. This conventional current flows from positive to negative. Positive means what? Here, positive means always it is considered to be higher potential. Negative means always it is considered to be lower potential. Now difference now. Conventional current flows from higher potential to lower potential. Normally practical oriented current will flow from lower potential to higher potential. Remember this, very important. Conventional current always flow from positive to negative. Right? Normal flow of electrons will flow from low potential to higher potential. Now, circuits, that is your next topic. Right? What is a circuit, children? For example, we switch on the switch, fan is rotating. That is your simple circuit. Right? Now, I have some components with me. Right? Now, I show that to you, children. Now I have a battery here. Right? So now I have an LED light. Right? Now I have some wire. Right? So when I combine this, at the end of this video I will show you this. Right? If I combine this, it makes a circuit. Right? So these circuits, we use some symbols and draw it. That diagram is called circuit diagram. For each component we have one symbol. This battery will have one positive and negative node. So that we will denote like this. Right? So this bulb, LED bulb we will use. So that will not only LED bulb, any bulb will be denoted by this symbol. Right? You will learn in detail in the further classes. Right? Now this wires, no children. So this lines and all will denote the wires. Right? Next one is here. This current, no children, is indication. that indicates the flow of current, and here always in circuit diagram we have to denote the flow of conventional current which will flow in the direction of positive to negative. So always denote the current from positive to negative. How to identify positive? The longer line is positive, shorter line is negative. Always while drawing a circuit diagram, mark it. Okay. Now when you are drawing the circuit, when you are connecting any circuit, it is connected in two types. One is in series circuit and another one is in parallel circuit. Okay. Now series circuit means in one good lifetime example you can say. Have you ever seen in any festivals, right? Or in our any functions at home, we used to have serial lights, right? In serial lights, have you ever seen if any one bulb is gone to repair, if the full board will not work, where and all it is connected, right? So now the electrician will be very tough, will be having a very tough time which bulb has gone wrong, right? So one bulb is gone wrong, the others also will go wrong. The reason I will tell you. In series circuit means series circuit is end to end, right? One end of the terminal, like either positive or negative, that will be connected to the other one, and this one end will be connected to the another one, right? So this circuit, series circuit is otherwise called as end to end circuit, right? Now what happens now here in this circuit? Current will be the same, I will be the same, voltage will be different, and as the number of bulbs increases, see here if I use one bulb, it will go with more power. If I two bulb, a dimmer one. If I use three bulbs, it will go still more dimmer, right? So as the number of bulbs increases, this voltage will be varying for everything. Current will remain the same in series circuit, right? But the voltage will be shared among all the bulbs. So it goes dimmer and dimmer. So what is the equation for series circuit? Total voltage V is equal to sum of voltages of individual bulbs. Okay. Now coming to the parallel circuit. This is what I said, children. At series circuit, if not the same current only is flowing here, right? For example, if this bulb is not working, what will happen? Current will come here, here it will come. After this, it cannot pass on to the next bulbs. So what will happen? If this bulb is gone wrong, the connected bulbs till here it will glow. After this, the entire bulbs will be not working. That's why in functions and all, serial bulbs will be very difficult to handle. Every bulb has to be maintained very properly. Right. Next one we are going to this equation. You must concentrate, children. Series circuit. You can have a remembrance, children, to avoid confusion. Series, that I is coming here. No. I denotes what? Current. So in series circuit, current will remain the same. So like this you remember. It will be easy for you, right? Voltage will be different. Different voltage. V1, V2, V3. So total voltage is equal to V1 plus V2 plus V3. Clear, children? Now coming to parallel circuit. Parallel, right? So it is both ends connected. Here one end is connected to other end. Here both the ends. See here, battery is here, right? Actually it is called a cell, children. One positive terminal and one negative terminal is called a cell. When a cell, more cells are interconnected, then that is called a battery. Right, now here it is cell. Now what will happen is both the ends are connected to both the ends of the bulb. Right, now another bulb is also connected, both the ends are connected. Here also both the ends are connected. This is the connection which we use in our house. Right, so for bulb, for tube light we will have one switch. For fan we will have another switch. Right, so each and everything is like one circuit, right, one complete circuit. So it is parallel connection. So one, if tube light doesn't work, it's not a problem, other appliances will work. Imagine if it is other way. If one thing is not working, all the appliances will not work if we connect the appliances at home in series. So what is the connection in our home? It is parallel circuit. Remember that. Now here, all the ends of the bulbs are connected. So it will be connected to the battery. Here, I had explained, I want to explain you this. The The path through electrons flow is called as circuit, and this circuit will contain one battery, wire and lamp, and wire if we will have one switch. Now usually we call battery to be source, right, lamp to be load. Source is the source of electricity, and where we get that electricity is called as load. That source and load, in between there will be so many components which we call it as wires and switch, right? Now coming back to this parallel circuit, here current remains the same, but in the parallel circuit potential will remain the same. Potential difference, which is otherwise called as voltage. Now current will be different, right? So different means what? I1, I2, I3, right? So total current will be the sum of individual currents. Here power will be the same. No, each and everything is one separate circuit. So dimming won't be happening over there, right? So these are the main points, children. So underline, very important. These types of circuit surely it will come in the 5-mark question. So we will see it in the activity now. Children, now I am going to demonstrate you about this two types of circuits as I told you. I have one source which is a battery, right? Now I have two battery here, and now I have two LED lamps, right? You can ask me what is this? It is called as resistor, because this LED lamp is a very, what is that? It is a weak instrument, a weak equipment. So if we use it directly in this high power battery, it can get damaged. So we use one another appliance called resistor. At this 8th standard, you people would have come across this, right? So this is called as resistor. We'll learn about this in detail in your higher classes, right? So it may restrict the flow of our current. It is just like stabilizer we use for fridge, right? So it will stabilize the current flowing into it, right? Now I have wire, a pad like this, and this in this red color will denote the positive charge, and black will denote negative charge. Now I am going to connect this, right? Now I am going to connect here. So here, so a circuit is made, a source. This is a simple circuit, right? A source connected with a battery. So this is positive and this is negative, right? Now I am going to connect a lamp with it, LED lamp. Now here you see, now can you see the bulb to be glowing here, right? So this is your what connection? Simple circuit connection, right? So battery, I hope you can see the battery, positive connected with positive, this is negative. This is your simple circuit, right? Now I am going to show you the what connection? Series connection. Okay, now I have this negative, positive. Now I am going to have another LED. With that I am connecting this positive here. Now I am going to touch this. Just watch. I told you end-to-end connection, right? So now I am connecting this one terminal over here with another one terminal of the battery. Now I am connecting these two. Now I am going to touch it with the other end. Now see what happens. Wait. See children, now I had connected both the bulbs. See, one end here and one end is connected with the other end of the bulb. Now this is connected to this. So this is end to end connection. So this is called a series circuit. Children, now you can see the parallel connection here. Now these two bulbs are separately connected to the battery here. So this battery goes for one connection and this red one goes for another one. So both ends are connected to the battery now. So this is one separate circuit, and this connection we call it as parallel circuit. So now I had demonstrated both the circuits. Underline the important points in your book. We will meet in the next video, children.